If you're a Java developer, your day-to-day activities while working on your projects include writing code, compiling code, testing the code, packaging it in the form of an artifact like jar or WAR file, and then deploying this artifact to a web server. That's a lot of tasks you have to take care of manually, and obviously you can automate these tasks using a library called Apache Maven. In this video, you will learn what is Apache Maven and how you can use it effectively to build and manage your Java projects. We'll start by learning the fundamentals of Maven, and step by step we will learn all the important concepts of Maven, including the advanced concepts like multi-module projects. So without any further delay, let's start the video. Hello and welcome to my channel Programming Techie, where I teach you how to build real-world web applications and improve your programming skills. If you're interested in this, subscribe to this channel and hit the bell icon to join us on our quest. So what is Maven? Maven is a project management tool which is developed to help manage projects which are developed using JVM languages like Java, Scala. The major tasks of a project management tool include building the source code, testing source code, packaging it into an artifact, and handling versioning and releasing of the artifacts, generating Java docs from the source code, and managing project dependencies. As you can see, Maven is responsible for doing lots of things, and for this reason, you will hear Maven is also called as a build tool or a dependency management tool. Now let's go ahead and see how to install Maven in your machine. I opened the website apache.maven.org in my browser, and when I go to the download section, you can download the latest Maven version here. And at the time of creating the video, the latest version of Maven is 3.6.3. After you downloaded the binary zip archive and extracted the zip file, the first thing we have to do is to create an environment variable in your system path called as m2_home. This is the place where other softwares and libraries look for the Maven installation, so it's similar to Java_home environment variable. So let's open the environment variable window and create a variable called as m2_home. And here I'm going to give the value as the path of the bin folder of the Maven installation directory. After this is completed, click on apply and OK. And to test whether the environment variable is correctly set or not, open a new terminal window and type mvn-version. So you should be able to see the Maven version including Maven home and some other details. So okay, we have installed Maven successfully on our machine. Now let's see how to configure Maven in an IDE. So IntelliJ already comes with a bundled Maven installation, so it's not really necessary to specifically configure the IDE unless you are working in a team. So in a team, normally you would work on one Maven installation across the whole project. So anyway, let's see how to configure Maven in IntelliJ. So in the IntelliJ welcome window, I'm going to click on configure, and after that click on settings. Then you will see a new settings window, and in there search for Maven. So here you can see the Maven home directory. It is pointed to the bundled Maven 3 installation. You can change it by clicking on the button you see on the to the right of this drop down and select the Maven installation directory. And once this is done, you can click on apply and OK, and you have configured Maven into your IDE successfully. So now it's time to create our first Maven project. So we're going to use IntelliJ IDEA to create the Maven project. After you open the IntelliJ IDEA in the welcome window, I'm going to click on the new project button. This will open a new project dialog box, and to the left side I'm going to select the option Maven and click on next. In this next window, we are going to provide the name of the project, Maven project demo, and I'm going to expand the option artifact coordinates, where you will see three fields: group ID, artifact ID, and the version. A group ID is like an identifier for your project, which usually follows the standard Java package naming conventions. So in our example, IntelliJ has already provided the value org.example. We can change it like com.programmingtechie. And the artifact ID is the name of the project we are creating. So I'm going to leave it as Maven project demo. And the version is a unique number which is used to identify the version of our project. So I'm going to leave the default value 1.0 snapshot. So if you're wondering what is snapshot, we will have a look at it in detail in the upcoming sections. So I'm going to just click on finish, and IntelliJ will create the Maven project automatically. Now let's have a look at the folder structure of the Maven project we just created. So if you expand the Maven project demo folder, you will see a folder called source, which is the root of our application source code and the application unit tests. So then we have some subfolders, mainly source main Java, which contains the source code of our application, and usually all the production code we write for the application is inside this folder. And then we have the source main resources folder, where we store all the static files we are going to use in our project. So the examples include some property files or any files where we need to read in our application, like an XML file, CSV file. If you're developing a web application, we will usually place all the static resources like HTML, CSS, and JavaScript inside this folder. Next, we have the source test Java file, where we stored the unit tests and the integration tests for our application in this folder. And the last part is the pom.xml, which contains the metadata of the project dependencies. So we will have a look at the project dependency. So we will have a look at what is pom.xml exactly in the upcoming sections. And the last one, and I forgot to mention one more folder called as target, which is currently not visible. But in this folder, Maven stores all the compiled Java class files, and we'll discuss about this also in the upcoming sections. One of the core components of a Maven project is the pom.xml file. The pom in the pom.xml file stands for Project Object Model, which contains the metadata of the project and is also responsible to manage the dependencies, to configure plugins, which helps us in automating many repetitive tasks. Here is how a basic pom.xml file looks like. So we have the project tag, which is the top level tag of our pom.xml file. This project tag encapsulates all the information related to our Maven project. Next, we have the model version, which represents the version of the POM you are using. For Maven 3, the model version is always set as 4.0.0. This number will never change unless you are using another major version of Maven. The fields group ID, artifact ID, and version we have already explained in the previous sections. So the group ID is a unique identifier of the project. The artifact ID is the name of the project, and the version is a unique number which identifies the version of our artifact. Now, as we know what is a POM file, let's have a look at different types of POM files. So we have basically three types of POM files. First, we have the simple POM file. So this is the POM file we saw previously. So this is just the file which is generated when creating a Maven project. It contains only information which is relevant to our current project. Next, we have a super POM file. This is a parent for all the super POM files. So it contains a lot of default configuration which is shared by all the simple POM files. You can find the super POM file inside the Maven installation directory under the path lib. And inside the jar file named Maven Model Builder, we can find a package named org apache maven model. So under the file, we have this pom 4.0.xml. So this is the super POM file I'm talking about. And next we have an effective POM file. So an effective POM file is nothing but a combination of simple POM and super POM files. So it's just a way of checking all the information of the pom.xml files just in one place. So we'll have a look at how this is helpful in the upcoming sections. But if you want to have a look at the effective POM file, all you have to do is go to our Maven terminal, type Maven help effective POM. So Maven takes a couple of seconds and then spits out the complete effective pom.xml file POM. So it's better to see this contents inside an IDE. So I'm going to open IntelliJ, and to the right side of the IntelliJ IDEA, there is a section called as Maven. If I click on it and right click on the Maven project demo root folder, you can see the option show effective POM. So if you click on it, so you can see the contents are similar to the super POM XML file. You will see the plugins information, which are the default information which Maven provides us. You can see a build section. You can see we will discuss about all these components in the upcoming sections, but it's just I'm showing it to you just to have a basic idea. So if you scroll all the way up, you can see the model version. The group ID is our group ID we mentioned in the simple pom.xml file, and also the artifact ID and the version are the same. If you're working on any non-trivial Java projects, chances are that you are mainly using some third-party jar files in your project to develop the application. These jar files can be anything like a framework or a library, like example, some JUnit framework, Spring framework, or maybe Selenium. These kind of external libraries are usually called as dependencies. Maven provides an excellent way to specify and manage these dependencies in our project through the pom.xml file. Without using Maven, you have to manually download the required jar files from the internet and add them one by one to your project. So Maven provides a dependency section in the pom.xml where you can specify the information of the jar you require in your project. This usually is the group ID, artifact ID, and the version. Once you have specified the required dependency information, Maven will automatically download these dependencies from internet into your project and adds them into the class path of your project. So now let's see how to add the dependencies to our the demo project. So now I opened the pom.xml in IntelliJ, and inside just below the version tag, I am going to add another tag called as dependencies. And all the required dependencies should go inside this dependencies tag. So to add a dependency, we were going to add JUnit 5 to our project. To add the dependency information, I'm going to open the browser and go to the site mavenrepository.com, and there I'm going to search for JUnit, and here I'm interested in the dependency JUnit Jupyter Engine. So I'm going to click on it, and here you will see all the information about this particular JUnit dependency, and you can see all the latest versions of the JUnit dependency, and I'm mainly interested in the version 5.7.0. So here you can see that we have this dependency tag, so we can just copy this information. I'm not going to include the comment, so I'm going to just copy this information, go back to my IDE, and copy this dependency inside the dependencies section. So that's it we have to do. So we have to force, after specifying this dependency, we have to force the IntelliJ to download this dependency. We can do that by clicking on this Maven icon you see on the top right corner. So once I click on the icon, this dependency is already downloaded into my machine. So you can see whether the dependency is downloaded successfully or not by clicking on the Maven section here. And if you expand the Maven project, you can see the section dependencies here, and I'm going to expand this again, and here we have the JUnit Jupyter Engine dependency in our project. So if you observe the JUnit dependency again, so we see some other dependencies inside JUnit Jupyter Engine dependency. So we have the API Guardian, JUnit Platform Engine, and JUnit Jupyter API. So these dependencies are called as transitive dependencies. That means they are dependencies of our dependency. If I try to expand also the JUnit Platform Engine dependency, we see we have again the API Guardian API, OpenTest4j, and JUnit Platform Commons. So the main caveat of having all these dependencies, transitive dependencies, is over the time these dependencies can increase a lot, and they can create a lot of mess. So I'm going to explain this with an example. I'm going to add another dependency called Spring Boot Starter Test. So this is the dependency which will enable us to test a Spring Boot app. If I go back to Maven section, you can see that we have the Spring Boot Starter dependency, and if I expand it, you can see that we have JUnit 4 dependency as a transitive dependency of Spring Boot Starter Test. So if I write some tests in my project and try to run them, there will be a conflict. In our class path, we have both JUnit 5 and JUnit 4. So we have to manually exclude this JUnit 4 dependency to make sure that our tests are working fine. To do that, I can just add an exclusion tag inside the dependency tag, so which looks something like that. We have added an exclusion tag, and inside that we have an exclusion tag, and inside the exclusion tag I'm going to specify the group ID of the dependency and the artifact ID of the dependency I want to exclude. And if you open the Maven tab again, you can see that the JUnit 4 dependency is no longer visible inside the dependencies section. A Maven dependency can be categorized into two ways: a snapshot dependency and a release dependency. A snapshot dependency generally means that a project is under active development. If you're working on a project in a team, chances are that you are following some kind of iterative process where you go through the phase of first developing the software, and at the end of the phase, you release the software to the end users. So at the time of developing the software, we mainly use the snapshot versions for the dependencies. And once the software is released, we will use the release versions. So you can say that snapshot dependencies are unstable and the release dependencies are more stable. We can control the visibility of a Maven dependency using dependency scopes. There are 5 types of scopes available for Maven dependencies. The first one is compile. This is the default scope for all the dependencies, and the dependencies marked with compile are available inside the class path of the project and are also packaged into the jar file. The second one is provided, which is similar to compile but with small differences. A dependency with provided scope will be provided at runtime either by JDK or the web server. A good example of the dependency using this scope is the servlet API dependency. The web server, which is running our project, provides the servlet API at runtime. So the dependency will be available in the class path of the project, but it will not be packaged into the jar file or war file. Next, we have the runtime scope. As the name suggests, the dependency marked with runtime scope are available only at runtime but not at compile time. A good example in this case is the MySQL JDBC connector dependency. By marking this dependency as runtime, you can make sure that we don't use the MySQL JDBC classes in our code instead of the standard JDBC API. The next scope is test. These dependencies are only available at the time of writing and running the tests. So the examples include JUnit and Spring Boot starter test dependencies, as you can already see in our pom.xml. And lastly, we have the system scope, which is similar to provided scope, but only difference is we explicitly mention where we can find the dependency in the system. So instead of a JDK or a web server providing this dependency at runtime, we provide the system path where Maven can find this dependency. You can provide the path using the system path tag. So in the previous sections, we saw how Maven manages and automatically downloads the dependencies into our project. So the next question is, where exactly does Maven stores these dependencies? Maven stores it inside a special directory called as repository. So we'll have basically 2 kinds of repository in Maven. The first one is a local repository. This is a directory or a folder which is inside the machine where the Maven is running. The default location of the local repository is under the user home and inside the .m2 folder. So next we have the remote repository. This is a website where we can download the Maven dependencies. So this can be a repository provided by Maven or maybe a custom repository setup inside an organization using software like Artifactory or Nexus. So now let's go into more details and see how Maven resolves the dependencies. So first, whenever we define a dependency inside pom.xml, Maven first checks whether the dependency is already present inside the local repository, that means inside the .m2 folder. And if it is not able to find this dependency here, then it tries to connect to the remote repository and it will download the repository and store them inside the local repository. So we can define the repository in our pom.xml by just adding this repository tags just below the dependencies tag. So here we have the repository, and with an ID, I've just provided the my internal site as the ID. And to the URL, we will usually provide the URL of the remote repository. In our case, it can be the URL of the Artifactory or Nexus repository. So till now we have learned the core concepts of Maven. Now it's time to deep dive and understand how Maven builds our projects. So Maven follows something called as a build lifecycle to build a project, and this lifecycle is divided into 3 different steps. So the first step is called as default. So as part of this step, Maven performs a lot of tasks. So if we zoom into a bit up into the default step, we'll see that first we have some different phases. So as part of these steps, we have different phases inside these steps. So the first phase is validate. So as part of this phase, Maven reads our pom.xml and validates whether we have valid XML here or not. So if there are any errors when creating the pom.xml, those are identified as part of this step. Next comes the compile phase. So as part of this phase, as the name suggests, Maven will compile our source code and create the class files, and it stores it under the target folder. So the next step is test. So as part of this step, Maven runs our unit test inside the project. And after this step, we have the package phase, where Maven packages the source code into an artifact of our choice. So this can be a jar file, a war file, or EAR, or maybe also zip file. After the package phase, we have the integration test phase. So if our project contains any integration tests, so these are executed as part of this phase. And after the integration test phase, we have the verify phase. So as part of the verify phase, Maven checks whether the integration tests which are run in the previous phase are successful or not. And after the verify phase, we have the install phase, where Maven will install the created package file. So it may be a jar file or whatever artifact which was generated. It installs it into our local repository. So that means the .m2 repository folder. After the installation, Maven will try to deploy this created package into the remote repository. So if the remote repository is configured in our settings.xml and poms.xml in our pom.xml, then Maven tries to deploy this package into that remote repository. So these phases are inclusive of each other. So if we run compile, so then we are implicitly also running validate. If you are running test, so as part of this phase, we are running validate, compile, and test. So if you are running install, that means you're running validate, compile, test, package, integration test, verify, and also install. So now let's discuss about the next step inside the Maven lifecycle called as clean. So this step is mainly responsible to clean the compiled Java classes or whatever metadata which was generated as part of the default lifecycle phases. So for this reason, you will see this clean step together with the lifecycle phases. So the famous example for this is the Maven clean install command. So what this command exactly does is it first as part of the install phase, as I told before, it compiles the source code, it runs the unit test, it creates the jar file, and then installs this jar file, and then installs this jar file into the local repository. And before doing all that, it will make sure that we are starting this phase in a clean way, so that it will clean all the previously generated class files and metadata from our project. So the next step is the site lifecycle step. So this is responsible to generate Java documentation which is present inside our project. All these three lifecycle steps and also the phases contains some additional phases which I'm not going to cover in this tutorial, so that will make it more advanced and more confusing for the beginners. So for this reason, I'm going to link the documentation section, where you can go to the Maven documentation and refer these phases in much more detail. To be able to execute the lifecycle phases we saw in the previous section, Maven provides us with different plugins so that we can perform each task in the lifecycle. So Maven plugins are not only used to execute the lifecycle phases, but to automate the other repetitive tasks as part of your build. So Maven provides us with different kinds of plugins. The plugin ecosystem is very huge. So there are lots of things which we can find to automate the repetitive tasks in our build. So each plugin is associated with a particular goal. So let's have a look at each of the plugins and the associated goals for these plugins. The first plugin we are going to talk about is the compiler plugin. This plugin is responsible to compile our source files as well as test files in our project. This is similar to running javac command for the whole project. So now let's see a demo of how to use this plugin. Inside the pom.xml, all the plugins must be defined under the build tag. So we will usually define this build tag under the dependencies section. And inside the build tag, I am going to define a tag called as plugins. And inside the plugin section, I am going to define the compiler plugin, which has the group ID as org Apache Maven plugins. and artifact ID as Maven compiler plugin. At the time of preparing the video, the version is 3.8.1, and after defining the plugin, we can test it by opening the terminal and typing the command Maven compiler compile. Here compiler is the name of the plugin and compile is the goal associated to the plugin. This goal will trigger the compile lifecycle phase in the Maven build lifecycle. So if I now press enter, you can see that Maven has nothing to compile in our project because we did not create any Java classes. So let's go ahead and create a Java class quickly. And I'm going to run the command again. So now you can see that Maven scanned the project and detected some changes and compiled the Java classes into the target folder. I previously explained about target folder. This is the folder where Maven stores the compiled class files. So you can see the class files under the target folder and under the classes directory. Maven also compiles the test files in our project. So let's go ahead and create a Java class inside the test folder. And now I'm going to run the command Maven compiler test compile, which will compile all the test classes in our project. And this command is going to execute the test compile goal. And so now you can see that Maven compiled our test classes into a different folder called as test classes under the target folder. So if I open the target folder, we can see the hello world test class file under the test class folders. We can also try to execute these commands from IntelliJ instead of running from the terminal. We can do that by first clicking on the Maven tab to the right side of the IntelliJ IDE. You can find this tab to the right side of the IDE, and under the plugin section, expand the compiler plugin and click on the compile goal. So you can see that the compilation failed because the Java compiler version of Maven inside IntelliJ is configured to Java 1.6. By default, we can change those settings by changing the configuration of this plugin. So I'm going to add a new tag called as configuration under the Maven compiler plugin, and inside the configuration tag, I'm going to provide the source and target properties as 15, which is the Java version installed on my machine. By adding these properties, Maven will use the Java 15 version to compile our class files. After adding these properties, if I try to click on the compile goal again, you can see that Maven compiles our project without any errors. The next plugin we are going to talk about is the Maven Surefire plugin. Using this plugin, we can run our unit test inside our Java project. To configure the plugin in your project, add the group ID of the plugin as org apache maven plugins and artifact ID as Maven Surefire plugin. At the time of producing the tutorial, the latest version of the plugin is 2.22.2. Once you have configured the plugin, you can open the terminal and type maven clean test. And here the clean command will make sure that we run our test in a clean state, and the term test will run the test goal of the Maven Surefire plugin. Once I press enter, you can see that Maven will first delete the existing contents inside the target folder and then compiles the Java classes and the test classes and then runs the tests in our project. After the tests are executed, we can see a simple report on how many tests are executed successfully and how many have failed. The Surefire plugin also generates an XML report inside the target folder. This report can be used to visualize the test results in a CI environment like Jenkins. The Maven install plugin is used to run the install lifecycle phase in the Maven build lifecycle. It compiles our source code, runs the unit tests, packages the source code into an artifact, and then installs the artifact into our local repository. To define the Maven install plugin, I am going to add another plugin tag inside the plugin section of our pom.xml file, and I'm going to use the same group ID as the previous plugins, and the artifact ID is going to be Maven install plugin, and the version is 2.5.2. Once this is configured, open the terminal again, and this time let's run Maven clean install, where install is the goal of the Maven install plugin. Once I press enter, you can see that Maven is running all the previous build lifecycle phases like compile, test, package, and at the end you can see that it's installing the package jar file to my local repository. This jar file is first generated inside the target folder, and Maven then copies this jar file into the local repository. The Maven deploy plugin is used to run the deploy lifecycle phase in the Maven build lifecycle. It runs all the phases which are included as part of the install phase and then deploys the created artifact to the remote repository. To be able to deploy the artifact to the remote repository, you first need to specify the remote repository details inside our pom.xml file. To do that, I'm going to open the pom.xml file and add a tag called as distribution management above the dependencies tag. And under the distribution management tag, I'm going to add the repositories information. So to uniquely identify the repository inside of pom.xml, I added an ID tag and a URL tag to point to the URL of the remote repository. In our example, I do not have access to any remote repository software like Artifactory or Nexus, so that's why I provided a dummy URL. So now if I go to the terminal, type maven clean deploy and press enter, you can see that Maven throws an error that it cannot connect to the remote repository. This is expected, but as we are working with a dummy remote repository URL, but if you are working in an organization which uses either Artifactory or Nexus, then the deploy phase should work just fine. Till now, we have covered the fundamental aspects of working with Maven. Now let's deep dive into some advanced concepts like multi-module projects. In the real-world projects, the application you're working on is usually divided into various modules, and we can maintain the source code of these modules effectively by using the Maven multi-module projects. As you see in the image on the screen, we can define a parent POM which acts as a parent for different child modules, and these child modules can have some nested child modules. In this way, we can modularize our whole project based on a particular functionality, and we can use multi-module projects to actually do this. Now let's go ahead and create the multi-module project using IntelliJ. Under the root folder of the Maven project, I'm going to right-click and select New Module. This will open the Maven module window. In here, I'm going to provide the module name as Child Project 1, and if I expand the artifact coordinates section, you can see Maven automatically generated the required group ID, artifact ID, and version. I'm going to change the group ID to the same group ID we used for the parent module and click on Finish. So now you can see the Child Project 1 module inside the project window, and if you open the pom.xml under the root folder, Maven automatically added the module details to the pom.xml, so you can see the Child Project 1 inside the module section. If I open the pom.xml under the Child Project 1 module, you can see that the Maven project is defined as the parent for the Child Project 1 module. So I'm going to create a couple of more child modules in the same way inside the project. So now you can see that we have 3 child modules inside our project, and we still have the source folder under the parent project. So I'm going to copy paste this folder under the child module, and after that I'm going to delete this folder as this is not used anymore. So now if you run the Maven install command on the parent project, Maven will scan through the whole project and understand that we have child modules and will start building them automatically. Maven uses something called as a reactor, which is responsible to scan the whole project and identify the parent and child Maven projects. So if there are any dependencies between our child projects, as we saw in the image previously, Maven reactor will make sure that our Maven reactor will build our project according to these dependencies. When you're working with multiple Maven modules, you may be working with different dependencies in different modules, and chances are that you are maybe using similar dependencies in multiple modules. For example, if we have JUnit as a dependency in all our child projects, there is a chance that we can by mistake use a different version of the dependency, a JUnit dependency, in one child module and another version of the dependency in another module. We can manage the dependencies and its versions in a centralized location inside the parent project with the help of dependency management tags. By maintaining the version of the dependency in the parent module, we can have a single place where we can manage all the dependencies inside all the child modules. Let's see a demo of how to use this dependency management in our project. Inside the parent pom.xml, I'm going to create a dependency management tag above the dependency section, and I'm going to move all the dependencies inside the dependency section of the dependency management tag. Now you may ask, what is the difference between adding the dependencies under the dependency management tag and just leaving them under the dependencies tag? By default, the dependencies marked inside the dependency section are available also for the all child modules. For example, if I'm going to leave the common slang dependency under the dependency section and move all the remaining dependencies onto the dependency management section, if I open the pom.xml of child project 1 and check the dependency tree by typing the command maven dependency tree, you can see that the common slang dependency is available to the child project 1 but not the other dependencies. To access the dependencies which are marked inside the dependency management tag, we have to manually define the dependencies inside the child project 1. So for example, if I want to use JUnit 5 inside my child project 1, I can define the dependency by providing the group ID and artifact ID. In this way, the child projects can control which dependencies it needs, and it actually solves a problem that all the dependencies which are defined inside the parent are not also present inside the child module. Going forward, if your project is very big, then this will avoid the dependency hell. So this is a best practice we have to follow in our projects. We can also manage the plugins inside our Maven multi-module project similar to the dependencies. To manage plugins, we have the plugin management section inside the pom.xml, and each child project can choose the plugin it needs from the plugins which are available. So this is how our parent pom.xml looks like after introducing the plugin management tag. The plugin management tag also goes under the build tag. So as we just moved the plugin section from under the build tag to under the plugin management tag. So in this way, we can also lock down the plugin versions we like instead of using the default Maven plugins which are configured inside the superpom file. Profiles can be used in Maven to create customized build configurations in our project. This means we can customize the behavior of our builds based on some specific conditions. For example, sometimes we need to test whether the source code packaging is working correctly or not. In that case, we may want to skip the test execution because the build process may take longer. In those cases, we can create a profile which will skip the test execution. We can configure this profile in our pom.xml by adding the profile tag, and inside the profile tag, I am going to provide an ID for this profile, and I'm going to declare the Maven test skip property, which is the internal Maven property by default. I'm going to set this value as true. So when we activate this profile while running the build, Maven will make sure to skip the test execution. So let's go to the terminal and type maven -p skip tests clean install, where -p stands for the profile option, and I provided the ID of the profile, which is skip tests. And you can see that the build was successful and Maven did not execute any test as part of this build. So this is the end of the tutorial. I hope you learned something about Maven through this tutorial, and if you liked it, please don't forget to like this video and subscribe to the channel for more upcoming tutorials. I will see you in another video.